Okay, now if we have the standard form, then we would solve this equation, right? Now, x is your unknown. We're solving for x. A, h, and k stand for numbers. Your vertical stretch, your horizontal shift, and your vertical shift, right? You don't need to know that. They're just numbers. So once you get the equation, you just treat all these things as numbers. So the obvious first step that you're going to make is you're going to subtract k from both sides, right?
Yeah.
So you're going to get, I'm going to write out every step in detail as you should. Okay, there's our equation. We do minus k on this side and minus k on this side, giving us a times x minus h squared equals negative k. All right? Okay, then what do we do?
Divide by a.
Divide both sides by a. Very good. So now, we divide by a, we divide by a. So that x minus h squared equals negative k over a. And now what do we do?
Square root.
Square root. Okay. And what, well, yeah, you think of we want to square root both sides, but really you have to go back to the fact that the solution to x squared equals c is x equals c, or x equals square root of c negative square root of c. Right? Because this is something I see people forgetting a lot. And there's still a lot of people who take an absolute value equation, just throw away the absolute values and think there's one solution. Most people are doing that correctly. It breaks into two solutions, and we understand how that works. And we just saw an example where in factoring the quadratic, we broke into two solutions, right? Okay? They can't always factor, but you always can use the quadratic formula, right? If you're in standard form, you don't have to factor and you don't have to use a quadratic formula. We're almost there. It's really easy to solve. Okay? So this tells us that, okay, now, x minus h is something that's squared that's equal to this, right? So it means x minus h equals plus or minus the square root of negative k over a. Just applying this. Now you got to be careful to understand this and how it applies to give you this. Okay, so this equation is an instance of this, except it's not x, it's x minus h. Okay? There it is. You have to use this carefully. You have to write it down correctly. You have to understand what it means and why it's true. If x squared equals 4, then what's x equal?
Square root 4.
Well, maybe. Because the square root of 4 is 2, and let's see, 2 squared is 4, right? That works. What else could x equal?
Negative.
Negative 2, right? And there are two solutions. So if something squared equals 4, then that something could either be 2 or negative 2. If the absolute value of x equals 2, then x is equal to 2 or negative 2, right?
Yeah.
Okay? So we have to be aware of this. Anyhow, we get this, so x equals h plus or minus the square root of negative k over a. Right? Now, we can say there are two real solutions. If negative k over a is positive, one repeated real solution if k equals 0, and two complex conjugate solutions, and we'll define what that means. It's fairly simple. If negative k over a is less than 0, because if negative k over a is negative, you're taking the square root of a negative. It's going to be then the square root of negative 1 times a positive, which is going to be square root of k over a times I, right? Then you get h plus or minus the square root of k over a times I, which are complex conjugate solutions.
I got one question.
Yeah.
I got kind of lost, but let's say so x equals h plus or minus the square root of negative k.
Yeah, well, I didn't actually write out this step, but if we'd add h to both sides, right?
Okay, so, all right, I got it.
So I probably, since I'm writing out every step, I should have. So here, and then here, okay? And I did leave that step out. Make sense?